Hello everyone. In today's lesson, we're going to be looking at Waec physics practical and how to plot graph. So in this this class session is made solely for the purpose of plotting graph. So we want to look at how to plot graph. So without taking most of our time, let's just quickly go into graph plotting. Here you see I have some tables here. So I have some tables here, and this is another table, and I also have one here. So this one pertaining to the same question. So what I'm going to do, as time permits us, we're going to plot the graph of whatever they ask us to plot here. We already have them here. So we already have the tables here, like I said earlier. Now this table here that you have here is one of the most difficult values that you can have to plot against each other. The reason being that in this graph, you have to plot a graph of m against n. So this is m and this is n. If you look at this part here, the values are easily straightforward. You can see that we have 1, 3, 5, 6, 7. So you can easily choose a scale of 0.1 unit to represent the values here. That's very easy. But for this, the values are so close to each other. So the values are between 0.965 and 0.996. So the reason why I choose these values is simply because of this. Now sometimes you may be asked to start even with these values like this, as close as they are. You may be asked to start the graph from both the origin. So you are going to start both axes from the origin. That means you are going to start it from 0, 0. Then sometimes when the values the examiner see that the values are so close, they will not tell you anything. They won't say whether to start it from the origin or not. Well and fine. If you have that, it's going to be very easy. So what I'm going to do today now is to plot this graph using starting both axes from the origin and without starting both axes from the origin. So I'm going to plot this twice. As time permits us, I'll go to this and plot this again. Trust me, by the end of this video, you find out that no matter how the values are arranged, you still be able to find your way through to plot this graph. So okay, let's quickly plot the graph now. Now before we continue, I want you to note this, because why this in the last exam, they asked some student to plot they asked the student to plot some values on the ordinates and the other on the abscissa. So here the abscissa means the x-axis or the horizontal axis, while the ordinate means the y-axis or the vertical axis. So you should always take note of that, and you should always prepare ahead for your physics practical. Physics practical is where you have to gain a lot of points. It's very important that you get a lot of mark from physics practical if you follow the due process and the instructions thoroughly and what to do. I have a video on the Waec marking guide for physics practical, so you can search through my channel, and when you search through it, you're going to see that video. Okay, so you're going to see the video or that video on how to answer this question. I'm still going to explain some of that on this lesson session also. Okay, so let's start plotting the graph. So what you're going to do is this. Right here we have to plot m against n on the vertical. So m is pretty straightforward. So I can easily divide this into 0.01. And again, when you want to plot your graph like this, look at this. This value ends at 0.76 and the least value is 0. So what you do is take this to 0 and shift this to 1, because you're looking at these values here. So they are more than 5. So each time you have values like that are more than 5, just shift them to 5. But assuming you have values that are less than 5, shift the values to 5 and divide it by 10. So what I mean is that, so if I take this to 0, I'm going to take this to 1, just like this. So when I divide 1 by 10, that's going to give me 0.1. Now this, what I've just done this in this part here is that I've been able to set out my scale on this axis. So what that means is that, now look at this. If you look at this, your graph, I'm sure that your standard graph has 12 2 cm each. So this is 2 cm. From here to here is 2 cm. Another 2 cm, 2 cm. So when I do this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see that I've been able to divide this into 10 places already on this, and my scale would then be 2 cm. So my scale would then be 2 cm to 0.1 unit on that M axis. So that's how I'll be able to determine my scale. Of course, you know that the values will not get up to 1 because the highest value will just have the 0.766. So by doing that, you can also shift this upward a bit. Okay, and you should always know that you should not always start your graph from the bottom of your graph paper. The reason why you should not do that is that if they ask you to get the vertical intercept and it becomes negative, then you find problems with that. Okay, so what I'm going to do now, so let's take this. This is 2 cm to another 2 cm for cm. So I'm going to start my graph because this is going to fit into 0.07. Then I'll shift it to this point and check for the horizontal axis and check whether if I can start it from this part. If it doesn't fit into all of this, if the horizontal axis doesn't fit on it, then you can start it from this point. Okay, the essence of doing this so that you have enough space to write. So let's go to this again. Now remember that the first part, I don't want to start it from the origin. So what I'm going to do is this. Since I don't want to start it from the origin, I'm going to look at this value here, the list value here. That's 0.965. There are many things that I can do to this 0.965. So I can take it down to 0.90 as my starting point. I can take it to 0.95 as my starting point. So these are possible starting points. So if I take this to 0.90 as my starting point, then what I will do is this. Now look at this value, 0.9. So I'll also take it to 1 because it's closer to 1. So I'm going to shift it up to 1. So when I shift it up to 1, then I'm now going to do this. 1 minus 0.9. So that's going to give me 0.1. So it means that I'm going to divide this from 0.95 to 1. I'm going to divide it equally into 0.1 to represent 2 centimeters. Okay, so what that means is that if I come to so when I count this again, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not going to be up to 10 values. So I'm going to start my graph from here. So if I start it from here, I'm going to get my 10 values. So that's how you normally plot your graph. So if I'm starting it from 0.90, but if I'm starting from 0.95, please always ensure that do not give gap. Do not draw your y axis or the axis and give a gap, but always start it from there. You indicate that this is your origin from that place. So if I'm using this, that's what I'm going to do. Now if I'm using 0.95 as my origin, then I'm going to have, again, the highest value is 0.96. So I'm going to have 1, I'll push it to 1 minus 0.95. So that becomes 1 minus 0.95. So that's going to give me 0.05. So what that means is that 2 cm on this will be 0.05. So if I do it this way, this would be from here. If I start my origin from here, this will be 0.05. 0.05. So what you have to do is just to be adding 0.05 plus 0.05. That's going to give me 0.1. Okay, so that's 0.1, and this will be 0.15, 0.2, okay, 0.25. Remember that it's 0.95 already, so it's not going to be 0.05. So what you now start to add it to the base. So this is 0.05. So our basis was 0.95. So I'm going to add 0. So you need to take note of that. 0.95 plus 0.05. That's going to give me 0.95 plus 0.05. that gave us, okay, when we subtracted, we did 1 minus 0.95. Okay, that's going to give us this. Then you now divide it by 10. So I've not divided it by 10. So you're going to divide that by 10. 0.05 divided by 10. So that's going to give me 0.005. That's what that means. So it means that each of these will be 0.0. So if I start from here, I have to start to add it from that base, because I'm starting from 0.95. So I'm now going to have 0.95 plus 0.005. So that's going to give me 0.955. So this is going to be 0.955. Then I'll add plus 0.005 again. So this is going to give me, so the next one is going to be 0.96. That way you go do it upward. Now, if you look at the values on this, see that the values are not going to be, they are not going to be as arranged when I set my base to 0.90. So you have to also look at that. So if I'm in the exam hall, what I will do is to go with 0.90. So that will be easier. So what I'll just do, I'll just come to this place. Then I'll draw my x axis through, my y axis through this point now. So that's what I'm going to do, because that's where I'm going to have enough space for it. So I'm going to draw this. So you can extend it downward. Okay. So you now put 0 for y axis. Then you put 0.90 for x axis. So that's how you start it. You put 0 for y axis. You put 0.90 for the x axis. Assuming it was this way, so this way you're going to put your 0.90 for y axis, and you put 0 on this side for the x axis. So now we can now put the point. So our starting point 0.90, then we are going to then be adding 0.1. Remember when we did 0.90, we had 0.1. Then you divide that by 10. That's going to give us 0.01. So let me take that again. We started from 0.90. 1 minus 0.90. So that's going to give us 1 minus 0.90. So that's going to give us 0.1. That's the space between the numbers here. That's the space between the numbers. So you have to divide it by 10 to get 0.01. Okay. When you now get 0.01, so when we start from 90, so what you're going to do is 0.90 plus 0.01. So what would that give us? That's going to give us 0.91. So that means this will be 0.91. This will be 0.92, 0.93, 0.94, 0.95, 0.96, 0.97, 0.98, 0.99, and 1.00. So I've been able to write out this point on this. So that's how easy it is. So for the other side, we can easily get that from what we said, 0.1. So you have 2 cm, 0.1. You can say 10, 0.20, 0.30, 0.40, 0.50, 0.60, 0.70, 0.80. So you see the highest value is 0.76. So we can stop at 0.80. Then I'll put on this part m. There is no unit for m because it's just an honorary number. Sign e, the sign of any angle is just an honorary number. For n too, there's no number for it. So I'm going to draw my x axis on this side now. Okay, so you're supposed to draw your x axis. Okay, so I've my point has been written out or drawn out. So the next thing I have to do now, another thing you have to look at is that these values may be very difficult for you to read out of this. So I have a very short way to write this out. So what I'm going to do is this. Now let's look at this. The gap between this and this is 0.10. So count the number of small lines: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The small number of small squares, that's 10. So I'm going to divide 0.10 by 10. So that's going to give me 0.01. So what that means is that each of these small squares has a value of 0.01, whatever m is. Okay. Now, what would 0.74? How many small buses or square buses would then represent 0.74? So what I will do is this. I'll divide 0.74, 0.174. I'll divide it by 0.01. That's going to give me 17.4. So I'm going to write it out, 17. So this is m as is. You can use pencil to do 17.4. Then you see when you divide 0.394, when you divide 0.394, when you divide it by 0.01, that's going to give you 34.9. When you divide 0.500, that will give you that will give you 50. Okay. When you divide 0.643 by 0.01, that's going to give you 64.3. When you divide this by this, that's going to give you 76.6. So I'll draw it with a pencil, then I'll write n on this side. Now for n, let's look at the gap between them. We already know the gap between them. If I from the scale with this, so it's 0.91 divided by 0.90 minus 0.91 minus 0.90. That's going to give us 0.01. Okay, so that's the gap between them. So if we have 0.101 as the gap between this, now you count the number of small square buses. They are 10 also. So you divide this by 10, and that's going to give us 0.001. And that is similar to what we were using at the beginning. So I have 0.001. Then it therefore means that each time, now remember our starting point is now 0. If I want to read 0.965, then I'll divide it by 0.01. But because you already know that our base does not start from 0, it starts from 0.90. So the first thing I have to do is this. When I want to read 0.996, I'll first do 0.996 minus 0.90. Our starting point here. Can you see that now? Then I'll then divide the answer by this 0.001. So that's going to give me okay, I think so I'll do this 0.996 minus 0.90. So that gives me this. Then I'll now divide this by 0.01. So that's going to give me 96. So I'll then count 96 from here. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 91, 92. Okay, so let's record that down. So before we start plotting, so that'll be 96. So that's 96 that we got there. Then the next one, 0.986. So I'll have to subtract it from the base, which is 0.90. So I'll do 0.986 minus 0.90. So that's this. Then I'll divide it by 0.01. So that's going to give me 86. So I'll write 86 here. Then if I go to the next one, 0.985 minus 0.90, that will give me this. Then see, if I divide this by 0.0, it's going to give me 85. Then I'll go to the next one. The next one is 0.966 minus 0.90. That will give me this. When I divide it by 0.0, it's going to give me 66. Then I'll do the next one, 0.965 minus 0.90. So that's going to give me, when I divide this by 0.001, I'm going to get 65. Now that's not time for me to plot this. So if I want to plot the graph, now I'm done with this, I won't be looking at this again. So what I'm going to do now is this. So I want to plot. I always like to start from the horizontal axis. So I want to plot 96 against 17.4. So you now start to count from here. This is 10 from here. This is 10, 20, 30, 40, 50, 60, 70, 80, 90, 91, 92, 93, 94, 95, 96. So this is 96. Place your ruler on this and count 17 plus 4. So you can't get 17.4, but you know that 0.4 should be in between 17 and 18 boxes, so you can't. So this is 10, 20, this is 10, 15, 16, 17. Then somewhere in between here, put a dot and circle it. Next, so the next one will now be 86 for 34.9. So you count from here again. 10, 20, 30, 40, 50, 60, 70, 80, 85, 86. Put your ruler on it. Then we are going up to 34.9. So that should be close to 35. So this is 10, 20, 30. This is 35 here. So I'll put my dot here close to that and draw it. So this time around, you're going to be using your description. Next, I'll go for 85 or 50. So this is 10, 20, 30, 40, 50, 60, 70, 80, 85. Then I'll count 50 upward. So this is 10, 20, 30, 40, and 50. So I'll put a dot here. Then I'll circle it. Next, I'm going for 66 and 64.4. So this is 10, 20, 30, 40, 50, 60. Then I'll go to 64.3. So this is 10, 20, 30, 40, 50, 60, 61, 62, 63, 64. So my discretion, I just put a dot here and circle it. Next, I'll now go for 65 for 76 point. Oh, okay, it was supposed to be 66. So this one was supposed to be on this side. So nevertheless, so it's still the same thing. That's why you always need to use a pencil. So I'm going to for 65 for 76.6. So this is now this is 10, 20, 30, 40, 50, 10, 20, 30, 40, 50, 60. Oh, okay. The first one was supposed to be 66. So let's cancel that. So this is 60, 65, 66, and I'm going 64 upward. So this is, I'll just go up 10, 20, 30, 40, 50, 60, 61, 62, 63, 64. Then I push it this way. Then I put a dot. So that's the correct point there. So this one is not correct. Always use a pencil. Then the next one, 65 for 76.6. So obviously this is going to be 65 here from counting. So this is 10, 20. We are going 76.6, 20, 30, 40, 50, 60, 70, 75, 76, 77. 76.6 should be at the middle like this. So we've drawn this. Then the next thing we have to do is to find the line of best fit where we can draw 3 straight lines. So you see that I can draw my straight line across these 3 with this one here and this one this way. So just separate them into 3 and draw. So that's that for that. Then you can determine the slope by drawing a large triangle on this. So the slope is going to be a negative slope. So I'm going to draw this. Always draw a large triangle. Some students, they have found the habit of using small triangles. So my slope, so this is delta m and this is delta n. Okay, my slope is going to be like this. My slope is going to be a negative slope. So it's going to be, because it's falling down like this, so it's going to be from this point. I'm going to read this point off like this. That's 0.10 minus then the upper part like this. You can use that scale factor again. So if you count from here, this is 10, 20, 30, 40, 50, 60, 70, 75, 76. So 76, you're going to do 76. So on this, we use 0.01 times 0.01. So that's going to give us 0.76 minus 0.76 divided by, then you look at this point here, trace it downward. So you can also use the same scale factor, or you can just read it from there. So this will be, okay, so just count. This is 10, 20, 30, 40, 10. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 95, 96, 97, 98, 99. So we are going to do 99 times 0.01. That's our scale factor. 99 times 0.001. So that's going to give us 0.099. Now remember, our starting point is 0.90. So we are going to have 0.90 minus that. So that's going to give us 0. Okay, I'm coming. So that's 0.90. Okay. Also, you can use these 2 points here. Just look at these 2 points. Just count this 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 times 0.001, our scale factor. Then add it to 0.99 plus 0.99. So that's going to give me 0.999. So just add it to this value. Just use the two values here. So that's going to give us 0.999 minus. So this other point here, you can read this point directly from here. So that's what I always like to use. So this is the midpoint between these 2 points. So you can just add 0.96 plus 0.97, then divide it by 2. That's going to give you the value in between this. So that will be 0.965. 0.965. So when you subtract 0.10 minus 0.76, that's going to give us minus 0.66 divided by 0.99 minus 0.965. So that gives you 0.025. So when you divide that, 0.66 divided by answer, that's going to give me minus 26.4. So that's my slope. So we've been able to answer the first part, starting both axes from the origin. Now the next one I have to do is to start it with without starting both from the origin. That's the first one that I did. So the second one now is to start it from the origin. So I'll just flip this and take another graph point. So this time around, since we have to start it from the origin, we are going to start both of them from 0, 0. So we already know what to do with this one. So this one will have no problem with that. So what you are going to do, this is where our problem is. We are going to center our attraction now. So what we are going to do is this. Since we are starting from 0, 0, so we are going to take this to 0. So the least value is going to be 0, and the highest value is going to be above this, which is definitely going to be what? 1. So this time around, 1 minus 0 is equal to 1. So you divide 1 by 10, that's going to give us 0.1. So it means that we're going to divide this into 0.1, but the values are going to be, the graph is going to be very close to each other. That doesn't mean anything as long as you can show the graph. So again, let me draw my vertical axis. Okay, I'm going to there are some things I didn't put in the first the other graph, so I'm going to put them now. So let's see. I'm going to start this from here. Okay, I'm starting this from the edge for obvious reasons that I explained in the other part. Okay, so this would be, as usual, we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. Then I'll put my axis here. That's so that will be enough for this because of we have the values here. So that will be M axis. Then on this side, I'll have my N axis. So on this side, since we have taken our division to be 0.1, so I'm going to have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0. So the values, because the values are between, they are going to, in fact, the graph is going to be stringed into this point here. That's how it's going to look like, but there's no problem. So this time around, so you now look again, we can look for the because we are using the same scale factor for this, so it's going to remain, M is going to remain the same like that. So I'm going to write M again. So 17.4, 34.9, 50.0, 64.3, 76.6. So for N, our scale factor will not change. So the numerical value between this and this 0.1, the number of small squares is 10. So we're going to do 0.1 divided by 10. That'll be 0.01. So we're going to divide these values. We are going to divide these values by 0.01. So if I divide this by 0.0, I'll just move this. That will be 99.6. Then this would be 98.6. This would be 98.5. This would be 96.6. And this would be 96.5. So we are going to plot it that way. So now let's see. So we are going to use this again now. So on 96, so for 96.6, so we'll just count from here. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 95, 91. So this is 99. 99.6 should be between 99 and 100. So we'll just count it up. So we usually try to put this. So we'll count it up to 17.4. So this is 10, 15, 16, 17. So I'm going to put my dot here and circle it. Next, we'll go for 98.6. In fact, this is 90, 95. Okay, 95, 96, 97, 98.6 should be in the middle. Or you can just put it here, count it up, then before you count it up before you count to the right, so that you don't make mistakes. So this is 95, and we are going to 34.9. That is almost 35. So this is 10, 20, 30. So this is 40, but we are going to 98 points. So I move 1, 2, 3, then the little dot in between 0.6. So you see, it's going to be stringed along all of this. That's how the graph will look like. Then the next one, go to 98.5. Okay, for 98.5 for 50. So again, this is 95. So we'll count up 10, 20, 30, 40, 50. So this is 95, 96, 97, 98.5, somewhere around this point. So just description this time around, you put a dot like this. Then the next one is 96, 96.6. So this would be, so let's count. This is 10, 20, 30, 40, 50, 60, 70, 80, 90. So this is 90. So we're going to 96. So for 64.3, so this is 10, 20, 30, 40, 50, 60, 61, 62, 63, 64. Remember, we're going to 96. So this is 95. 96.3 is 96. So just leave it at 96. Okay, you circle it this way. So that's what you're going to get. It's going to be a straight line between, almost a straight line, but that's what you're going to get. That is how it's going to look like. Then the last one is 96.5 on 76.7. So the same thing. This is 95 and 96.5, almost close to what we had there. So, but we'll take it to 76. So this is 10, 20, 30, 40, 50, 60, 70, 75, 76. So we can't one, okay, this is 6 here, somewhere around this place, then in between for 76. So that's what we have. So we can now draw our line of best fit on this 3. So if you draw it on this 3, this one will be up, this one will be down. So that's exactly how it's going to look like. So I'm going to draw it upward so that it will be a little bit big. Okay, so let's get the slope. This time around, I'm going to get the slope. So I can't use this part that is off. So I'm going to use inside of any part that touches this. So I can use this part. Let me draw this up again. So I'm going to use this part here. Okay, to this part. So the slope is going to be a negative slope also. So you see, I can just read off this point here. So this is 0.8. So this should be 0.9 from the tip here. So my slope, so we'll start from here. That's 0. So this should be midpoint between the midpoint between 0.4 and 0. So that be 0.45. So I have 0.45 minus the top here. That's 0.9 divided by, then I'm going to read this point downward this way. I'm going to trace this point and read it off here. For this is 0.95, 96, 97, 98, 985. So 0.985 minus, so I'm going to read this other point part downward, 0.9. So this will give us, let me bring out my calculator. So this will give us 0.45 minus 0.9. That will give us minus 0.45 divided by 0.985 minus 0.9. So that will give us 0.085. So I'll divide the top by the number 0.45 divided by my answer. That's 0.45 divided by 0.085. So that's going to give me minus 5.29. So that's my slope on this. Then something that I omitted from that, you have to write the title of the graph. So you have to write M, graph of M against N. There are no units that you need to state the unit. Then the scale used on this, which you have already said, on both sides is even the same. So the scale is 0.1 or 2 cm to 0.1 unit. There's no unit for this. So the unit we have is just unit on the M axis. Then 0.2 cm to 0.1 unit on the N axis. So do not use Y and X, and you can use vertical or horizontal axis. Okay, so that is what we'll have for this. So you always state the scale and the title of the graph. Okay, so because of time, I won't be plotting the other graphs again. So let's look at some of the precautions that you can come up with. So for question 1, which has to do with upthrust, these are some of the precautions that you can make use of. 1. I avoided parallax error when taking readings from the spring balance. So you must always state the instrument that you are taking the parallax error from. Don't just say I avoided parallax error. You must state that you are avoided parallax error when using a particular instrument, whether it is a meter rule or spring balance, whatever the instrument is. 2. I noted and corrected 0 error on the spring balance. Please do not say I avoided 0 error. It will be marked wrong for you. So this is the way you are going to state it. I noted and corrected 0 error on that instrument again, on the spring balance. 3. I ensured that the masses do not touch the bottom of the beaker. Okay. Then 4. I ensured that the masses were fully immersed in both water and the liquid. So of these precautions, some of them may be stated in the instructions in the question. If they state any of this, let's say for example, completely immerse the masses fully, don't state it as your precaution again. Okay, so once they state whatever they state in the question, do not state it as a precaution again, because it has already been stated in the question. If it is not stated in the question, then you are going to state that. So you can always make use of error due to parallax. I noted and corrected error, 0 error on the spring. So in this case, they may ask you that in these two parts, it may be possible that they ask you not to allow the masses to touch the bottom of the beaker. So do not state that if it is stated. But if it's not stated, you can state it as what? A precaution. Then number 2, optics, rectangular glass prism. I avoided parallax or error when using the protractor and the ruler. See, I'm stating the instrument that I'm using now, because I'm going to measure with a ruler and a protractor. So you have to state that clearly. I ensured clean and neat traces. Before stating this, ensure that your traces are neat. If your traces are not neat and you are stating this, you are going to be penalized. Okay. I ensured reasonable spacing between the pins. So this one is one of the precautions that may be stated in the question. So if it is stated that you should put them within reasonable spaces, do not state it again. I ensure that the pins are vertically erect or upright. So this can also be stated in the instruction. But anyway, you can still go with all of this. But if they are stated in the instruction, please do not state them again. Then next, electricity. I ensure tight and clean connections. That's a very good precaution that you can state. I avoided parallax error when using the galvanometer or meter bridge. So you avoid that. Then I noted and corrected 0 error on the galvanometer. Again, you can also include the meter bridge. The meter rule on the meter bridge can also be, you can also note that and also correct that. I ensure that the key was always opened when not taking reading. You can say you ensure that the plug is always removed when not taking reading. I avoided dragging the jockey on the meter bridge. So do not drag the jockey or slide the jockey. So you can use slide instead of drag on this part. So you avoided sliding the jockey on the meter bridge. So that's a precaution that you can take. And finally, do not state any precaution already stated in the instruction as explained earlier on. Okay, if there is any question that you want to ask, you can ask your questions on the comment section. I'll be replying all of them as the video goes on. So do not forget to subscribe if you have not yet subscribed, like, share, and as usual, your comments are very important for the onward progress of this channel. Good luck as you prepare for your physics practical tomorrow. All the best.